All right. After having looked at alkanes and alkenes, we're now going to look at alkynes. So alkynes have at least one triple bond within that particular structure. So as long as I have one triple bond, I can categorize that entire molecule to be an alkyne. So the general formula is CnH2n minus 2. So if I've got 5 carbons in my alkyne and there's only one triple bond, I can figure out the number of hydrogens pretty easily. So 2n is 5 times 2, which is 10, minus 2 would be 8. So C5H8 would be an alkyne. And just as we learned in our introduction, the prefixes stay pretty consistent throughout our organic chemistry, right? So these prefixes apply to alkynes as well, but the difference has to do with the ending. So instead of it ending in ENE or ANE, it would end in YNE. So this is for an alkyne. And just like we learned about in alkenes, it is not possible to have methyne. And again, I want you to think about why it is impossible for us to have methyne. So having learned that, the rules are pretty much the same from this point on, right? So you have to incorporate our triple bond into the longest continuous carbon chain. You have to name any side groups appropriately, and you want the lowest numbers possible. So taking a look at this particular example, I'm going to try and find my longest continuous carbon chain. So if I go 1, 2, 3, 4, 5, that's actually not my longest continuous carbon chain. And this is where you might have to start thinking a little bit outside of the box in terms of what our longest chain might be. So if I see here, I can clearly see the carbons. I've got 1, 2, 3, 4, and then 5, 6. So it is possible for me to have a longest continuous chain of 6 carbons. So I'm going to try and achieve that. And then it's about numbering from left to right or right to left. So I'm going to try both ways and we'll see what works for us. So 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. So numbering from left to right, I get the triple bond between carbon 4 and carbon 5. Not really a huge fan of that, because if I go from right to left, my triple bond is between carbon 2 and carbon 3. So I really would prefer to have that between carbon 2 and carbon 3. So I'm going to get rid of the left to right numbering so that I can just keep that right to left. I'm pretty confident that that is the correct answer, right? So having done that, I know that I end up with this little bit as my side group. And in my side group, I've got 1 carbon, which tells me that's a methyl group. So doing all of that, I can name this all together. So I've got 6 carbons, so that's hex, and 1 triple bond, so hexyne, so YNE. And just like we did for the double bond, so the triple bond is between carbon 2 and carbon 3. Instead of having to say all of that, I can just give it the lowest possible numbers here. So carbon 2. So I'm going to do 2 hexyne. And then the only thing that I have left over is to put in my side group. And my side group is attached to carbon number 4 of the parent chain. So that means that I'm going to do 4 methyl, and there is a dash here. I want to make sure that that's clear, and a dash comes after the methyl as well. So 4 dash methyl dash 2 dash hexyne, and that is how I name this particular molecule. Okay, here's another example. This time I've got 2 different triple bonds. So let's try and number these. Again, I'm going to go left to right and right to left to see whichever one is lower. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I've got carbon number 1 and 3, or 2 and 4. I like 1 and 3 much more than I do 2 and 4. So I'm going to go with that numbering. So right to left, that is. So I'm going to get rid of this. So this is exactly like our double bonds here, except the ending is different, right? So I've got pent, but there's 2 of these triple bonds. So I'm going to do pentadiene. And the numbers are 1 and 3. So 1, 3, pentadiene. Okay, and that's how you'd name that particular compound.